Hello, welcome to ANS Solver. This is the ninth question of the paper. So as you can see, they have given you, an integration, and I've asked you that A should satisfy this equation. So as you can see, this concept is called something like bypaths, okay, which has an important concept called as isolate, where I is the inverse, okay, L is the logs, A is the algebra, okay, T is the trigo, and E is the exponents. Okay, if you see x here lies in algebra and cos 1 upon 3x lies in trigo. A comes first or A comes before trigo, so I can take my u as x and I can take my v dash as cos of 1 over 3x. Correct? Basic concept. Now my u dash, which is the differentiation of x, is 1, and v, which is basically the integration of cos 1 over 3x, the integration for cos I know is sine 1 over 3x over 1 over 3, which can be written as 3 sine 1 over 3x. Now I can use my formula uv, okay, with the limits minus the integration with the limits vu dash. So now u into v is basically 3x sine 1 over 3x with the limits 0 and a, correct, minus the limits 0 and a, and vu dash, which is simply 3 sine 1 over 3x dx. Okay, so now what I can do is I can split this. So I can first put a here in the equation. So I get 3a sine 1 over 3a minus 3 into 0 and sine 1 into 3 into 0. Okay, so I'll basically just get 3a sine 1 over 3a. Okay, now what I need to do is I need to integrate this. So now the integration of sine I know is minus cos. So this is minus 3 cos, it's the same 1 over 3x. So I'll just remove this bracket here. Okay, over 1 over 3 with the limits 0 and a. So I can basically write this as minus 9 cos 1 over 3x with the limits 0 and a. This is 9, okay? Now, what I can simply do is I can write this as minus 9 cos 1 over 3a, okay, minus 9 cos 1 over 3 into 0, which can basically be written as minus 9 cos 1 over 3a, okay, plus 9, I know cos 0 is simply 0, 1, sorry. So now I can write something like this. So now writing everything together, I can write this as 3a sine 1 over 3a. There's a minus here in the middle, and then I have minus 9 cos 1 over 3a plus 9. Okay, so now cos 1 over, I'm just confirming one thing, yeah, so I have this, correct, it is equal to, I know, is 3. Okay, so now what I do is I can write this as 3a sine 1 by 3a plus 9 cos 1 by 3a minus 9 equals to 3. Here I can take 3 common to get basically a sine 3a, sine 1 upon 3a plus 3 cos 1 over 3a minus 3, which is equal to 3. So now what I can do is I can basically write this as a sine 1 over 3a plus 3 cos 1 over 3a minus 3 equals to 1, because 3 and 3 get divided. So now I can basically write this as a sine 1 over 3a equals to, when I take 3 that side, I get 4 minus 3 cos 1 over 3a, which now I can write as a equals to 4 minus 3 cos 1 over 3a over sine 1 over 3a, which is basically what I needed to prove. Now, verify by calculation that a lies between 2.5 and 3. So first you can write this equation as a minus 4 minus 3 cos 1 over 3a over sine 1 over 3a. Okay? Don't write equal to 0, it doesn't matter. Make sure you are on the radians mode. And now what you do is, first take your a as 2.5, then you take your a as 3. So write this basically as 2.5 minus 4 minus 3 cos 1 by 3 into 2.5 over sine 1 by 3 into 2.5. So what I can do is, I can basically write this as, I can write this exact same thing on the calci. Just give me 1 second, I'm just writing it. Okay. So yeah, this is basic manual stuff which you need to do. Okay. Once you know the concept, you can just solve any sum of iteration. Numerical solution. So here I get my answer as minus 0.787. I care about more about the sign. Now when I put 3 in the place of 2.5, just put 3 in the place of 2.5 in the calci. Okay. So when I do that, just give me 1 second. I get my answer as 0.17269, which is positive. So now I can say that a lies between 2.5 and 3 if the sign changes. Okay, that's the concept you need to know here between the critical values. So I can just say there's a change in sign, hence verified. Okay. Yes, so this is the third part of the question. So I know this is my iterative formula, okay? Just add n plus n's and n. Now what I can do is, I can take my n first as 0. When I take my n as 0, I get this as a1 equals to 4 minus 3 cos 1 over 3 into a0 over sine 1 over 3 with a0. Correct? Now what I can simply do is, I can take my a0 basically as 2 or 2.5 or 3, because I know a lies between them. So I can take, let's say, as 3. So now I can write this basically as 4 minus 3 cos 1 over 3 into 3 over sine 1 over 3 into 3. So now when I do this and solve this on the calci, the value I get is 2.82731. Now for A2, instead of the 3 here, I click on the answer button. Like remove the 3 and click on the answer button. Okay. When I do that and I click on equal to, I get 2.7646. Now for A3, again click basically on, just give me 1 second. I misplaced the formula. Just give me 1 second. Just 1 second. I'm just writing it down. Okay. So now when I do this, I get my formula as 2.7446. Now for A4, I again click on equal to to get 2.7386. Now for A5, when I click on equal to, I get this as 2.73618. A6 also I get this as 2.73618, and for A7 also I get 2.73618. Now if you see from the last 3 times this has been recurring, that means how many ever times you click on equal to, this is the answer you will get, for which you will basically get 2.736 as your final answer.